The sun is the primary source of energy in the solar system. It is what sustains the life of every living thing on Earth, because it provides the light and heat plants need to grow. Those plants, through photosynthesis, which is also connected to the sun, release oxygen that we all so desperately need. Solar radiation also heats the air in Earth's atmosphere, and it does this unevenly across the surface, which in turn creates a specific climate in particular geographic latitudes. Climate is shaped not only by the interaction of solar radiation with the atmosphere, but also by factors such as ocean currents, terrain features in some regions, and even human activity. But in this video, we will focus on only one factor related to the sun's activity. Since the flow of energy from the sun is not stable but constantly changing, many hypotheses have emerged, and later even popular myths, suggesting that the sun can significantly affect the climate as a whole. So in today's video, we would like to explore whether the distance from Earth to the sun affects temperature, how solar cycles influence the climate, whether solar radiation really burns up the atmosphere, and whether the sun is truly to blame for all of today's climate problems. So let's figure this out together. Without a doubt, changes in the distance between a planet and the sun play an essential role in climate change. The climate in different regions of the Earth will also change as the planet's axis of rotation shifts. Milankovitch was already talking about this in the last century. He identified several fundamental cyclic changes in Earth's orbit and its axis of rotation. One of Milankovitch's cycles is the long-period oscillation in the eccentricity of Earth's orbit due to interactions with other planets. Over time, the gravitational pull of the gas giants Jupiter and Saturn forces Earth's orbit to change from an ellipse stretched in one direction to one stretched in another. That is, it changes Earth's orbit's eccentricity. Eccentricity, just to remind you, shows how much the shape of an orbit deviates from a perfect circle. This process lasts for approximately 90,000 years. Global climate change caused by the cycle of changing eccentricity is minimal, because Earth's orbital oscillations are minor and have only a minor effect on climate. Another cycle is precession, the process by which Earth's axis slowly moves along a cone. The operation of a gyroscope is also based on this effect. Earth is like a gigantic gyroscope. When it starts spinning, the gyroscope rapidly rotates around its axis, and at the same time, the axis itself traces out a cone. The cause of this effect can be the gravitational influence of the sun and the moon. The overall precession of Earth's axis takes about 26,000 years. Axial precession gradually changes the timing of the seasons, forcing them to begin earlier. Right now, Earth is tilted so that in January, the northern hemisphere is tilted away from the sun, winter, and the southern hemisphere is turned toward the sun, summer. After about 13,000 years, the situation will be reversed. In January, in the northern hemisphere, it will be summer, and in the southern hemisphere, it will be winter. Since precession changes the direction of the axis, the celestial poles, as seen from Earth, will also be located differently relative to the stars. Right now, the north celestial pole is located near the North Star, and in about 12,000 years, because of precession, it will be located near the star Vega. These factors significantly affect the climate? Probably not. At the present time, Earth's axis is tilted by 23.4 degrees. But this angle is not constant. It changes very slowly with a specific period that is about 41,000 years. These periodic changes in the tilt of Earth's axis are called nutations. The moon is the main influence on this cycle. Earth's axis reached its maximum tilt approximately 10,700 years ago, when the tilt angle was about 24.5 degrees. It will reach its minimum tilt in about 9,800 years, when the tilt angle will be 22.1 degrees. Since the tilt angle of the axis is currently decreasing, this is gradually leading to increasingly mild winters and cooler summers, which, over time, allow snow and ice in high latitudes to accumulate into large ice sheets. As the ice cover grows, an ever larger portion of the sun's energy is reflected back into space. This contributes to even more cooling, This particular cycle significantly affects the global regional climate, but it is worth paying attention to its timing. The period of this cycle is extraordinarily long. Of course, the sum of all the cycles and their, so to speak, interference causes a gradual increase or decrease in the amount of energy from the Sun that reaches Earth. But this amount of energy can change only gradually, over thousands of years. Most often, this happens about once every 100,000 years. For example, the last ice age ended only approximately 12,000 years ago. So we will have to wait a very, very long time for the next one. As for warming, Milankovitch cycles today cannot explain the current global warming because it is happening far too rapidly for processes such as nutation. Or is it all the sun? In reality, solar activity is cyclical, reaching maximum or minimum levels, and accordingly can influence Earth's climate. Yes, this is definitely the maximum of solar activity. The photosphere of our sun has been observed since the time of Galileo Galilei. Back then, people first noticed sunspots on the sun. Sunspots are dark regions on the surface of the star where it is temporarily cooler by a few hundred kelvins and slightly darker compared to other areas. A large number of sunspots indicates significant activity, and a small number, accordingly, indicates low activity. Back in the 19th century, the German astronomer Heinrich Schwabe, after observing the sun for about 2 decades, concluded that solar activity is cyclical. The period of this cycle is approximately 11 years and can vary, plus or minus 1 to 2 years. The maximum of solar activity corresponds to the most significant number of spots on the star's photosphere, and the minimum corresponds to the smallest number. In addition, later studies confirmed that the sun's magnetic field also changes according to this cycle. There is also a myth about a 300-year or even 400-year solar cycle, and supposedly its maximum is happening now, which is why global warming is occurring. Even though we have been observing the sun since Galileo's time, we still do not have reliable data from that era. To confirm such a cycle, we would need observations for 600 or 800 years, or even better, 1200. Clearly, we do not have that much data for such a long period. Therefore, the idea of such a cycle simply could not have arisen from a scientific point of view. Someone might say, well, if you cannot confirm it, then you also have no right to refute it. Even though we do not have data for 800 years, we can reconstruct sunspot activity and model activity for the last several thousand years. The models refute all such cycles and any connection between this cycle and the 11-year cycle of solar activity, as well as modern global warming. Along with myths about supposed maxima, there are also myths about certain minima and coolings, or, as some say, global coolings, which contradict the latest observations of warming. Here, the answer can be brief. Even if such a minimum of solar activity did exist and had a significant impact on the climate, it would not stop the current global warming, and even less would it send us into an ice age. It could slow global warming a little. We would all like such a minimum to ease global warming. Still, observations and further forecasts do not yet point to anything like that. It is all harmful solar radiation. Many people cannot accept that they themselves are to blame for the planet might soon come down with a fever, and they claim that all this global warming is caused by the harmful effects of solar radiation. I think it is worth starting with the meaning of the word radiation. The word itself means emission and does not inherently contain anything harmful. It is all emission, all light, both visible and invisible to the human eye. Along with the light we see coming from the sun, we are also irradiated every second by other types of radiation. For example, ultraviolet rays, which we all love to get a tan in the summer. From day to day, the intensity of ultraviolet radiation fluctuates a lot. It also fluctuates together with the 11-year cycle of solar activity. During periods of maximum solar activity, ultraviolet radiation can significantly affect ozone concentration in the atmosphere and accordingly influence climatic processes. Let me remind you that the ozone layer absorbs most ultraviolet radiation, thereby preventing it from harming living organisms. Changes in solar activity alter the flux of high-energy charged particles, which during the maximum can strongly irradiate Earth. These particles are believed to be capable of causing various climatic changes when interacting with air at different layers of the atmosphere. Still, so far there is not enough convincing evidence that this is the main factor behind the current rise in temperature. And all types of radiation at the peak maxima of solar activity are far too small and insufficient to explain profound changes in our climate. I think many of our subscribers have seen the famous movie 2012. If you remember, all the global problems in it began because of solar flares, and also because neutrinos suddenly started interacting with everything. As a result, all of this feeds heavily into myths you can often find on the internet. Supposedly, once again, our beloved maximum of solar activity is generating a vast, even unprecedented over the last tens, and not just tens, but hundreds, and maybe somewhere even thousands of years, amount of solar flares, which in turn eject those terrifying cosmic rays and irradiate and sterilize our planet through and through. First of all, solar flares are not always directed toward Earth, and by no means do all those ionized particles reach Earth. Therefore, the increase in the overall flux of solar energy is insignificant. Second of all, the particles that do reach Earth can interact with the upper layers of the atmosphere and partially influence their weather. Still, they definitely do not affect the global climate, and even less so modern global warming. When we analyze scientific papers on solar activity, we find authors of other studies who not only deny the influence of solar activity on current global warming, but also conclude that this factor has the opposite effect. Indeed, some studies show a slight decrease in solar energy over the last few years, which does not align with global warming. They say that just a little more, and that is it. We only have to suffer with this until the year 2030, and after that, everything will just fizzle out. But seriously, we often hear in the media that climatologists are warning about catastrophic consequences that will last either until the year 2030 or after that, or however different people phrase it. Or they say that if the temperature rises by more than 1.5 degrees, a global catastrophe will be unavoidable. In general, this all started with a quote from a report from the year 2018 that was prepared by United Nations climate change experts. It said that if the global community wants to avoid a 1.5 degrees Celsius increase in warming, then all of us need to sharply reduce and limit all types of harmful emissions by the year 2030. By that time, carbon dioxide emissions should fall by 45% relative to the level of the year 2010 and reach a minimum by the year 2050. Where exactly did it say anything about the end of the world? I honestly do not know. If you want to check these words, the report is freely available online. I did not make anything up. This threshold of 1.5 degrees Celsius is a conventional boundary, and does not mean that if it warms by 1.6 degrees, the world will end. The consequences of global warming will gradually become apparent as temperatures continue to rise. But scientists say that a warming of 1.5 degrees will significantly raise sea levels, making it impossible for people to live in some coastal regions. An increase of that size in temperature will reduce coral reefs by another 70 to 90%. The number of plant and animal species may decrease, and along with that, crop yields will drop. And there are many other frightening consequences. No matter how much we blame our sun, we need to recognize that global warming is anthropogenic. There is a way out. We must reduce greenhouse gas emissions, develop new, cleaner industrial processes for making and producing anything, completely stop all harmful emissions, and learn to create less trash, because we still have to live on this planet for a long time. And we here is not just you and me, but every nation in every country in the world, because everyone shares responsibility for this. We should not be afraid that it is already too late, that the year 2030 is just around the corner. We need to act right now. That way, we will save not only ourselves, but the whole planet. That is all for now. If you enjoyed the video, leave a like and subscribe to the channel. See you next time.